NASA's shocking discovery with the James Webb Telescope will change everything. The James Webb Space Telescope, JWST, will change our understanding of the world of outer space and aliens. NASA's newest eye in the sky is about to set off to explore the mysteries of the universe, and some of its first targets are enchanting planets orbiting other stars. Join us today as we are going to have a look at its mission and goal. But before we move forward in the video, make sure to subscribe for more content and like this video for receiving similar suggestions from YouTube. Also, we highly appreciate your comments. Now let's get straight into the video. The mission of JWST. The Space Telescope's mission is to help scientists understand how we got here, from the interweaving of molecules, stars, galaxies, black holes, and planets that inhabit the universe, creating and combining the ingredients necessary for life to create a place called this Earth. Are conditions conducive to this thriving and noisy biosphere, often among the millions or perhaps billions of rocky planets that inhabit the galaxy? To find answers, JWST will observe hundreds, perhaps thousands of exoplanets before completing its mission. These will stare at a hellish lava world with a molten surface revolving around their star for hours on end. It will examine worlds that had somehow survived their violent star deaths and were now orbiting their remaining star corpses. It would gaze through the gas giant planet's atmosphere, search for newborn worlds among the dusty disks clinging to tiny stars, and flicker at some small rocky worlds that might look like Earth. Of the thousands of exoplanets we have seen in our galaxy, only a handful resemble the planets we see in our solar system. The others were undoubtedly aliens. The Milky Way's many planets. Like many of the most ambitious scientific and human engineering projects, JWST's journey to launch the pad was marked by technical delays and increased budgets. A dispute recently broke out over the telescope's name, but if all goes according to plan, this flagship telescope, believed to be the successor to the venerable Hubble Space Telescope, will provide plenty of scientific delight. JWST will see the universe primarily in infrared light. Once the giant golden eye opened, the observatory's extraordinary sensitivity allowed the telescope to spy on the first signs of stars and galaxies to inhabit the universe. This sensitivity will also help it directly observe the world of aliens, although the telescope was not intended for this purpose when it was designed. When the JWST was compiled in 1989, no planets orbiting other stars had yet been discovered. Planetary theory suggests that such a world must exist, but the first exoplanets were not announced until 1992. Exoplanet hunters such as NASA's Kepler Space Telescope recently discovered that worlds orbiting other stars in the Milky Way are as common as grains of sand on Earth. This abundance gives the JWST team an incredible opportunity to explore some of the world's most exciting in detail. By blocking out the light of their host stars on planets with an instrument called a coronagraph, JWST can directly display some of these paler and most distant worlds in orbit, even those that could still be in the stage of formation. Telescopes can see through Earth's extraterrestrial atmosphere and determine what the gas envelopes are made of and how they evolved during life on this planet, and it can read molecular markings in planetary daylight. Dissecting planetary atmospheres. About 6 months after arriving in space, JWST will begin to enjoy starlight and explore distant worlds. As the planets pass between their stars and the telescope, their atmospheres appear momentarily in silhouette lit by starlight. In this starlight, the net reads signs of gas through which the light passes. An extreme system box and planetary spinner were one of the Webb's early transit destinations, including WD-1856b, a giant planet orbiting a stellar corpse, and HD-80606b, a planet whose orbit is more like a one-sided star chain extending from a comet. These extreme systems could contain clues about how different types of planets formed and survived, and by studying the gases associated with many worlds, JWST will help scientists understand how planetary size, temperature, and evolution are related to climate and other properties. Most of the telescope's early observations will focus on hot Jupiters, a class of planets we don't see in our solar system. This vast world that orbits the stars for hours or days is one of the most common types of planets discovered by astronomers. The researchers will guide the 4 telescope instruments through their search for the ratio of carbon to oxygen in the planet's atmosphere, which contains information about where the planets formed. The team will also compare what Webb sees with previous observations from Hubble. Another interesting type of planet we don't see in the solar system is super-Earth or mini-Neptune. Worlds that are larger than Earth and smaller than Neptune, such as Gliese 486b, GJ 1132b, and K218b. Finding out whether these planets have atmospheres and what they are made of is critical to determining whether they are habitable. Natasha Batala, Natalie's daughter, is co-chair of one of the largest early exoplanet surveillance programs, which will monitor about a dozen of these mid-sized planets. Whether such worlds are habitable depends on where and how they formed and developed. Some could be clean cores of former Neptune, says Natalie Batala, reducing the chances of colonization. Others sit right on the border between the big red rock world and the small gas world, a transition that scientists don't fully understand. Another early target was hot rocky planets lying next to their stars, turning them into clumps of roasted charcoal rather than overheated bubbles. In this world, which includes 55Cancri and K2141b, clouds of rock and minerals can rain down on lava and create unimaginable landscapes. Creedberg wanted to know what the surface of the lava world called LHS 3844b is made of, and see if it has any unexpected little atmospheres associated with it. JWST will also target each of the 7 rocky worlds, roughly the size of Earth, in the TRAPPIST-1 system. These planets orbit a small nearby star the size of Jupiter, and 3 of them have a temperate climate. TRAPPIST-1e may offer the best chance of detecting Earth-like conditions among early targets, while TRAPPIST-1c, another early target, is closer to its star and likely to have temperatures similar to Venus. Taking pictures of planets. Not all JWST planet targets pass through their parent star. Some orbits orbit hundreds of times further from their star than Earth does from the Sun, and orbit in a system that we can view from top to bottom or bottom to top. Some early observations of exoplanets would directly depict the planets in this type of system and block out their host stars, even though the planets look like tiny lights in the image. Most of these observations will focus on large planets, gas giants, and possibly ice giants that are very far from their stars and therefore easier to see when the starlight is out. Such observations would allow scientists to learn more about the structure of the atmosphere, the types and amounts of clouds that may be present, and the relative amounts of molecules such as methane and carbon monoxide that could indicate the planet's birthplace. The long search for life. While JWST will change our understanding of the world that inhabits our galaxy, telescopes are unlikely to see any signs of life unless scientists are very lucky. This type of observation is just at the end of the telescope's capabilities and would require too much observation time. Finding biosignatures of aliens from distant space means looking for combinations of gases or chemical elements that scientists don't expect to create geological processes on their own. And while astrobiologists have some ideas about what we might be looking for, methane, ozone, and other metabolic byproducts, it is not clear what sign of alien life might look like. Early planetary targets included several rocky worlds the size of Earth, but they orbited tiny reddish stars that were susceptible to intense bursts of radiation that could sterilize their surfaces. Whether this world has an atmosphere is the first thing JWST is trying to find out. Over the course of a few days, all of this powerful potential lands on a rocket surrounded by dense rainforest stretching out into the warm, coffee-colored sea. Perhaps one day we will find out whether the lush forests cover alien landscapes, whether strange insects swarm in the distant atmosphere, and whether strange rivers and seas are also the cradles of life. The first step is getting to know our exoplanet neighbors, and JWST will help us see them in more detail than ever before. If you've enjoyed this video, give it a big thumbs up and do not forget to subscribe for more. Thanks for watching.